Hello, everyone. Welcome back to the ZinovyMed Podcast. I'm Dr. Ilya Rabkin. If you caught our last episode on the diet wars, you already know the internet has a way of turning basic nutrition into a contact sport. If you thought that was a battle, welcome to the front lines of the great oil war. If you listen to one group, you're told that seed oils are the hateful eight, a toxic, inflammatory sludge responsible for everything from brain fog to the downfall of modern civilization. But if you listen to clinical guidelines, you're told the opposite, that animal fats are the real villain, and that switching to oils like canola or soybean oil is one of the best things you can do for your heart. So who's really right? I've spent the last few weeks digging into the data to help tease out what's really going on, and more importantly, what actually matters in real life. Today, we're going to stop the shouting and start with science. We're going to look at a 100-year uncontrolled experiment on human nutrition, how fat actually moves through your body, what I call the lipid highway, and a controversial breakdown product called 4-HNE, which is sometimes nicknamed the zombie molecule. By the end of this episode, you won't just know which bottle to reach for at the grocery store. You'll understand why the answer isn't seed oils are poison or butter is evil. Before we start labeling fats as good or bad, we need to clear up one of the biggest misconceptions in nutrition. Cholesterol itself is not the enemy. In fact, if you had zero cholesterol in your body, you wouldn't even exist. Cholesterol is a structural molecule. Every single cell in your body is wrapped in a membrane, made largely of cholesterol and lipids. Without cholesterol, your cells won't hold their shape. They'd fall apart like a sugar cube in hot coffee. Cholesterol is also the starting material for hormones: testosterone, estrogen, cortisol, even vitamin D, all made from cholesterol. Your brain uses cholesterol to send signals. So when we talk about cholesterol, we're not talking about a toxin. We're talking about something essential, but potentially harmful in the wrong context. The real issue isn't cholesterol itself. It's how cholesterol is transported, how long it circulates in your bloodstream, and what kind of environment it's traveling through. Think of cholesterol like building supplies. Bricks are useful. Bricks scattered across a highway during rush hour, not so much. Modern heart disease science isn't about eliminating cholesterol. It's about keeping traffic flowing and preventing the crashes. Let's slow things down and get back to high school chemistry, because this is where most of the confusion really starts. But don't worry, there's no quiz at the end, unless you do your blood tests. Think of fat molecules like a long chain. That chain is made of carbon atoms, and those atoms like to hold hands with hydrogen atoms, kumbaya style. So there's saturated fat. With saturated fat, every possible hydrogen seat is filled. No gaps, no flexibility. The chain is stiff, straight, and rigid. That's why butter and beef tallow are solid at room temperature. They stack neatly like bricks, very stable, but not very flexible. Then comes the unsaturated fat. With unsaturated fats, some hydrogen seats are empty. To stay connected, the carbon atoms grab each other more tightly, forming these double bonds. These create bends or hinges in the chain. Within this category of unsaturated fats, we have monounsaturated fat, one hinge. Mono equals one, right? Think olive oil and avocado oil. And polyunsaturated fat, many hinges. Here's where the seed oils like soybean or canola live. Because the chain is bent and wiggly, these fats don't stack well. They slide past each other, which is why olive oil and soybean oil are liquid. They're flexible. Last, and definitely least, we have trans fat. Trans fats are the Frankenstein creation. In a lab, scientists take a naturally wiggly plant oil and chemically force it to become straight and rigid. Your body doesn't recognize these fats properly, and they're about as close to biologically harmful fat as we've ever created. Now, why does this one even exist? I think a little historical context is fun. In the early 20th century, food companies wanted the cheapness of plant oils but the stability of butter. You can't make a flaky pie crust with liquid oil. It just turns into a greasy mess. So scientists took those wiggly plant oils and blasted them with hydrogen gas. This forced the hinges to straighten out. The most famous example is Crisco, which launched in 1911. It was the first fake solid fat. Your body has no idea what to do with a straightened out plant oil. It doesn't just jam the docking bays in your liver, it practically welds them shut. It is essentially biological poison. Now, why does any of this matter? Because the stiffness of the bricks, or the fats, and the flexibility of the hinged fats changes how they behave once they enter your bloodstream. Oh, one more thing. Where do triglycerides fit in all this? I don't want to forget these because they don't get enough attention. Triglycerides are the main form of fat you eat and store. Most dietary fats enter your bloodstream as triglycerides. They're energy storage molecules, burned for fuel or stored for later. High triglycerides are often a sign of excess refined carbohydrates, excess alcohol, insulin resistance, ultra-processed food intake. So while cholesterol gets all the headlines, triglycerides are often the early warning light that metabolism is under strain. Now that we know the players, let's talk about how they took over our kitchens. Imagine it's 1870. If you wanted to cook a meal, your options were simple: butter, lard, or beef tallow. Seed oils were not part of the human diet. If you told someone you were cooking with cottonseed oil, they'd think you were trying to eat your shirt. Then came industrialization. We learned how to extract oil from seeds like cottonseed, corn, and soybeans using large presses and chemical processes. At first, oil was dark, smelly, and unpleasant. Over time, we learned how to refine it, bleach it, and deodorize it. In 1911, Procter & Gamble introduced Crisco, marketing it as cleaner and healthier than animal fat. It was a massive win for the food companies and the beginning of a large, unplanned nutrition experiment. Fast forward to the 1950s, heart disease rates were rising quickly. President Eisenhower suffered a heart attack, and the country panicked. Research at that time pointed the finger at saturated fats. The public message became simple: stop eating butter, eat vegetable oil instead. Since then, intake of linoleic acid, the main fat in seed oils, has gone from about 1% of calories to nearly 10%. We replaced fats humans had eaten for thousands of years with fats created through industrial processing. And that's why people are now asking, did we trade one problem for another? To answer that, we need to understand the lipid highway. Since fat and water don't mix, your body packages fat into particles called lipoproteins, what you see in your lab report as LDL, low-density lipoprotein, and HDL, high-density lipoprotein. LDL is often called bad cholesterol, but that's very misleading. LDL's job is to deliver cholesterol and fat to tissues that need it. LDL is just a delivery truck. The problem isn't the truck, it's the traffic. When LDL particles stay on the road too long, especially in an inflamed environment, they can become damaged. Damaged LDL can penetrate artery walls, triggering plaque formation. HDL acts more like a cleanup crew. It helps remove excess cholesterol from circulation and return it to the liver for recycling. And more recently, we have ApoB. ApoB is a protein found on every cholesterol particle that can contribute to plaque. Each LDL particle has exactly one ApoB. So ApoB tells us how many trucks are on the road, not just how much cargo they're carrying. More trucks equals more traffic equals higher risk. This doesn't make LDL evil. It means traffic control matters. Again, think of LDL like the delivery trucks. Your liver is the recycling center. It has docking bays or receptors that pull those trucks off the highway that is your bloodstream. So then why are we told that high LDL causes heart disease? Let's imagine the highway gets too crowded. The delivery trucks, the LDL, start sitting in traffic. While they're idling, they can get dented or damaged, and we call this oxidation. When an LDL particle is damaged, it crashes into the wall of your artery and gets stuck under the pavement. Your immune system sees this wreck and sends in white blood cells to clean it up. But if too many trucks crash, they form a pileup called a plaque. Over years, this narrows the road and eventually can cause total blockage. That's a heart attack. For decades, the diet heart hypothesis has told us a very simple story. Saturated fat raises LDL, and LDL causes heart disease. Case closed. And as we discussed, the biology is there. Saturated fats do definitely make those liver docking bays stiffer, keeping the LDL trucks on the road longer. But current evidence is teaching us that this story isn't a one-size-fits-all. It turns out the danger of saturated fat is highly dose-dependent and context-dependent. If you are metabolically healthy, meaning you have low inflammation, you're lean, and you're physically active, your body might handle those bricks just fine. In that context, a moderate amount of saturated fat from high-quality sources like grass-fed steak or a bit of butter isn't the heart attack in a box we once thought it was. The real trouble starts when you combine those bricks with high sugar, ultra-processed foods. When your lipid highway is already inflamed and your insulin levels are spiked, those LDL trucks become much more likely to crash and burn. Here's where fat type matters. When you eat a lot of saturated fat, those rigid brick fats make the liver's docking base stiffer and harder to open. The trucks stay on the road longer, which raises LDL cholesterol in the blood. This doesn't mean saturated fat is evil. but it does explain why cholesterol numbers respond the way they do. Unsaturated fats, especially polyunsaturated fats from seed oils, are way more flexible. They help the liver pull LDL trucks off the highway faster. This is why replacing saturated fat with unsaturated fat reliably lowers LDL cholesterol on your blood work. In long-term population studies, people who replace butter with plant oils tend to have a meaningfully lower risk of dying early, on the order of the mid-teens % in some analysis. These are observational studies, not randomized trials, but the signal is consistent. In randomized trials and systematic reviews, replacing saturated fat with polyunsaturated fat tends to reduce cardiovascular events, especially in high-risk groups. The key point is this: the benefit shows up when unsaturated fats replace saturated fats, not when they're simply added on top of a poor diet. We have to look at the bigger picture here. If saturated fat was the only villain, then our health as a nation should have improved when we started eating less butter in the 70s and 80s. But instead, obesity and type 2 diabetes skyrocketed. Why? Because we didn't just replace butter with broccoli. We replaced it with ultra-processed foods. Ultra-processed foods are the perfect storm. They're usually a combination of refined carbohydrates, sugar, and industrial oils. This combination does something far worse than just raising LDL. It causes systemic inflammation and insulin resistance. Think of it this way: high LDL from saturated fat provides the cars for the crash. But inflammation from sugar and ultra-processed living is what makes the roads slippery and the drivers aggressive. When you have high LDL and high inflammation, the risk of heart disease doesn't just add up, it multiplies. So while saturated fat does have a mechanistic link to heart disease via the lipid highway, many scientists now argue that the real driver of the modern obesity epidemic isn't just the bricks or the hinges. It's the factory-made frankenfoods that set our metabolism on fire. So the modern verdict? Saturated fat isn't necessarily evil, but it is a high-potency fuel. If you're using it in a high-quality, whole food diet, it's likely a neutral or even fine choice. But if you're stacking it on top of a standard Western diet, you're essentially adding more cars to a highway that's already covered in ice. Quality and context change everything. Now we get into the science of the seed oils. If seed oils are supposed to clear the highway of all that LDL, why is there even a war? Well, because those hinges from not being saturated that give the oils their mobility also make them fragile. Because the trucks may be carrying fragile cargo, those hinges, the double bonds that make the seed oil flexible, also make them fragile. If you leave a brick in the sun, it stays a brick. But if you leave a piece of fruit in the sun, it rots. When seed oils are exposed to oxygen, light, and especially high heat, they undergo lipid peroxidation. They break down. One of the breakdown products is a molecule called 4-HNE, the zombie molecule. At high levels, 4-HNE can attach to parts of your cells and interfere with how they function. In lab and animal studies, it's associated with poor energy production and increased cellular stress. It's like throwing sand in the gears of an engine. This is why critics worry that while seed oils keep the highway clear, they may be gumming up the engines of your cells. But here's what the critics often miss. The human body is not a petri dish. In a laboratory, if you blast a fat molecule with heat and oxygen, it falls apart. But inside a living, breathing human, we have an elite security team called antioxidants. Molecules like glutathione and enzymes like glutathione peroxidase are specifically designed to hunt down 4-HNE and neutralize it before it can touch your mitochondria. When we look at human clinical trials, even when people eat a diet high in these fragile seed oils, we don't see a massive spike in 4-HNE damage in their tissues. Why? Because as long as you have adequate nutrition, things like vitamin E, selenium, and a healthy metabolic rate, your body handles these molecules with ease. In fact, some research suggests that a small amount of this stress might actually make your cells stronger by forcing them to keep their antioxidant defenses sharp. It's a biological principle called hormesis. What doesn't kill your cells makes them stronger. The only time the zombie molecule actually wins is when the system is overwhelmed. That happens in two specific ways. One, the oil is pre-damaged. If you're eating oil that has been heated and reheated in an industrial fryer for days, the zombie molecule count is so high that your internal security team just can't keep up. Or two, the body is depleted. If you're eating a diet of ultra-processed junk, you likely don't have the vitamins and minerals your body needs to build those antioxidant shields. In the context of a whole food diet, the zombie molecule is a ghost story. Your body is built to handle it. The danger isn't the oil itself, it's the state of the oil and the state of the person eating it. Context always matters. And this brings us to the real culprit, the deep fryer problem. At home, you might cook with oil for 10 minutes. In fast food restaurants, oil is a workhorse. It sits in a fryer at around 400 degrees. It's heated, cooled, and reheated again and again, sometimes for days. Each cycle increases oxidation and breakdown products, including 4-HNE and trans fats. This is called thermal oxidation. So when studies say seed oils are healthy, they're usually studying fresh oil. And when influencers say seed oils are toxic, they're usually pointing at ultra-processed deep-fried food. The donut was always the problem, not just the oil. Now let's talk about the scary word inflammation. Critics say seed oils are inflammatory because they're high in omega-6, which the body turns into arachidonic acid. Arachidonic acid is like the 911 dispatch of your immune system. You need some inflammation to heal. But people fear that if we eat too much omega-6, we are constantly calling 911 for no reason. Inflammation isn't bad by default. You need it to heal. The problem is chronic, low-grade inflammation, the kind that never shuts off. Omega-6 fats get blamed because they can be converted into arachidonic acid, which plays a role in inflammatory signaling. But here's the key point. Omega-6 does not automatically mean inflammation. In real human studies, eating fresh seed oil does not consistently raise inflammatory markers like CRP. Inflammation spikes when omega-6 fats are combined with refined sugars, ultra-processed food, repeated heating, and metabolic dysfunction. Your body has a regulatory system. It doesn't turn every omega-6 molecule into a fire. The fire only starts if the oil is thermally abused in a fryer or packaged in a high-sugar, ultra-processed snack. So what's the final takeaway? Vegans and vegetarians, close your ears for a second. Let's be honest, a steak cooked in butter tastes so much better than a steak cooked in soybean oil. That's just a fact, sorry. Animal fats, tallow, butter, steak, they're stable. They don't turn into zombie molecules easily. If you're searing at 500 degrees, animal fat is your best friend. But they are the bricks. Eat too much and your lipid highway gets backed up. And seed oils, canola and soy, they're the most powerful tools we have to drop LDL and clear the highway. When used fresh or for light cooking, they are cardiovascular gold. But they are fragile. If you eat them from a deep fryer restaurant that hasn't been changed in 3 days, you're eating zombie soup. This isn't about good versus evil. It's about using the right tool for the right job. All right, time for the practical advice you have oh so patiently waited for. How to stock your kitchen. Your daily default should probably be olive oil and avocado oil. They have the stability of animal fats and the highway clearing power of seed oils. They are your best all-arounders in my opinion. Your heart health tools? Fresh seed oils. Don't be afraid of fresh canola or soybean oil and dressings. They are proven tools for lowering LDL. Just don't let them sit in the sun or the fryer. Then the high heat specialists, butter, ghee, tallow, and coconut oil. They are stable tanks. Use them for the sear, but don't let them be your main source of fat. The ultimate rule? Avoid the combo. The most dangerous fats aren't usually found in your pantry. They are found in the ultra-processed combo of sugar, refined flour, and abused oils. The Great Oil War has focused on the wrong things. The reality is clearly nuanced. You need the right tool for the right job, and stay away from the factory-made shortcuts. Please remember that this podcast is for education, not personalized medical advice. Everyone's situation is different. Genetics, medications, metabolic health, and existing conditions all matter. Always discuss major dietary changes with your healthcare providers. And finally, don't just take my word for it, or any podcasters. Read deeper. Look at the studies. If a paper feels overwhelming, upload it into an AI tool and ask it to explain the methods and conclusions in plain language. My blog at ZinovyMed.com/journal always includes citations and references for those who want to review the evidence themselves. Nutrition literacy is power. Cook with intention. I'm Dr. Ilya Rabkin. Thank you for spending this time with me. If this was helpful, please subscribe, like, and share it with someone you care about. Stay consistent, stay curious, and above all, stay healthy. I'll see you in the next episode.